In our last video, we saw how in a chemical reaction, the reactants and the products must be the same amount. So we showed a scale where the reactants were placed, models of the reactants were placed there, and models of the products were placed there, and the scale was balanced. The reaction that we did in that example was a reaction between hydrogen gas, which is diatomic because it's more stable that way. We learned that the 7 of them, Hanoth-Goldbriat, including hydrogen as well. Oxygen was also diatomic, and that formed water, H2O. We saw that there was a problem because there were 2 hydrogens on the left and 2 on the right, which was good, but there were 2 oxygens on the left and only 1 oxygen on the right, which was not good. So what we did was we put another water model on the right side. But by doing that, we have too many hydrogens because we have 2 times 2, which is 4 hydrogens. So what we need to do here is to write a 2 right there. There is a 1 here, which you technically don't have to write, but I'll write it for emphasis. And so we see that 2 hydrogen molecules plus 1 oxygen molecule will form 2 water molecules. This brings us to the law of conservation of matter, which we learned earlier in the year through one of our labs, that you are not going to be creating or destroying matter when you do a chemical reaction. Therefore, both sides, the reactants and the products, must contain the same number of atoms of each element. And so we come to the practice of balancing chemical equations. The general rule is start with the most complicated compounds and work your way down to the simplest, which would be elements. So we're going to balance the following equations. What we want to do is we want to put a blank in front of each of these to recognize that the only thing we're going to do is add a number in front of each of these formulas. So we look at the left side, we have 1 magnesium here, and we look at the right side, we have 1 magnesium here, which looks good. Then we look at the left side, and we have 1 O2, and an O2 means 2 oxygens altogether, versus on the right we have a 1 oxygen. So what we're going to do is we're going to multiply the right side by 2, so that we have 2 oxygens on the right to match the 2 oxygens on the left, so we'd have a 1 in front of this. Now, of course, by putting this 2, we also affected the magnesium. We have 2 magnesiums now on the right, but only 1 on the left, so we're going to add a 2 here, and so now we have 2 magnesiums to match 2 magnesiums, and 2 oxygens to match 2 oxygens. We'll move to the second equation. We'll put a blank in front of everything to remind ourselves that we can only add numbers in front of the formulas. And we're going to notice that oxygen is in several places. There's an oxygen here on the left in 1 spot, but on the right they're in 2 spots, 2 oxygens. So we're going to leave oxygen to the end. We're going to start with the other elements. Let's start with carbon. Here's carbon on the left. There's 1 carbon in this formula, and there's only 1 carbon in this formula. So therefore, we can just easily put a 1 here and a 1 here to remind ourselves that we already looked at those 2 blanks. Now we're going to move to another element, hydrogen. We're going to leave the oxygen to the end. We have 4 hydrogens on the left side, and right now we only have 2 on the right side. So we need to multiply this by 2 in order to have a total of 4 hydrogens on the right to match the 4 hydrogens on the left. Now we're going to shift our attention to the oxygen. We have 2 oxygens in the CO2 formula because 1 times 2. And we have 2 total oxygens right here because we have 2 times 1. So 2 plus 2 gives us 4 oxygens. So we have to multiply a 2 in the blank because 2 times 2 equals 4. And now we have the same number of oxygens on both sides. As we move to the third example, we're going to notice that every element only appears once on each side. So we can start with either element that we choose. So we could take a look first at the nitrogen. And we notice that the nitrogen, there's 1 on the left, and there are 2 on the right. So on the right, I'd put a 1, and on the left, I'd put a 2. Now let's look at the hydrogen. I have 2 times 3, which is 6 hydrogens, but on the right side, I only have 2 right now, and I want to have 6, so I'm going to put a 3 in front of here to match 6 hydrogens, which 6 hydrogens. Now the last element we have to do is the oxygen. We have 3 oxygens on the right, 3 times 1, And right now we have 2 on the left. So we have a couple of choices. Choice number 1 is to introduce a fraction or a decimal. So the question is, something times 2 gives us 3. The answer is 1.5 or 3 halves. 1.5 or 3 halves. So now that is mathematically correct, but then what you want to do is you want to change all these to whole numbers. So then you would double everything. So double, 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 double would give you a 4, a 3, a 2, and a 6. So those are going to be your final answers, 4, 3, 2, 6. Now let's back this up a little bit, and let's suppose that you really don't like decimals and fractions, and that's confusing to you, and you got to this point right here, and you realized that you needed to have 3 options on the right and 3 on the left, and you only have 2 on the left. A trick you can do is just to double it right away without doing this yet. So let's double this to a 4, double this to a 2, double this to a 6, and then let's do the oxygen now. So 6 times 1 is 6 oxygens, and so something times 2 is 6. That answer will be 3, and then you still have your final answer again. So if you're okay with the fractions and decimals, do them first, then double. If you really, really don't like them, double first, then add the last coefficient. So I would suggest that you pause the video right now, do this last example by yourself, and then see if you got it right. I'll now do that with you. So 2 carbons on the left means that you have to put a 2 in front of this carbon over here and a 1 in front of this. And then 6 hydrogens on the left, and we need to have 6 on the right, so I'm going to put a 3 in front of this. And now we do oxygen total. I left it to the end because it was everywhere on the right side, so I left it to the end. So 2 times 2 is 4, and 3 times 1 is 3. So 3 plus 4 makes 7. So I need to put a 3.5 here, or a 7 halves. And then I would double, 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 double to make 2, 7, 4, and 6. And we have just shown how to balance chemical equations to satisfy the law of conservation of mass.